Greetings, doctor. Hope you're having a nice day. My name is Mahmoud Fadil. Magic number AD220162. Group 1B. I was responsible for the introduction and the conclusion part of this project. Our project is about cement. Cement is basically the most important part of the mixture of concrete, the backbone of all our infrastructures, ranging from schools, factories, hospitals, roads, and many other more. And as I said, cement is also a mixture. It has so many materials and elements used in it. Some of them are calcium, aluminium, silica, and many other more. In this project, we're going to be discussing about all the materials used in cement, why are they used, how are they put together in the manufacturing process, from A to Z, and thank you.
So Wilson will continue to do the presentations for the material selection. So cement actually has many types in this world. For example, is the ordinary Poland cement, low heat cement, Poland pozzolana cement, and many types of this one cement in this world. Each cement has its own set of components that engineers can use to different jobs. In this assignment, we are only focused on the ordinary Poland cement, which is the most widely used type of cement in the world. So here is the constituent and the content that exists in the ordinary Poland cement. It has lime, silica, alumina, iron oxides, magnesium, sulfur dioxide, soda, and potassium. So lime actually takes as a major part in the ordinary Poland cement. So to increase the compressive strength, actually we can use the alkyl laminates, which is one type of the additive cement, and this is the sixth type of the alkyl laminate we select for many type of the alkyl laminates. So this is the result. Below the table is the result for the tested by tested the compressive strength of the cement by adding the alkyl laminates. So the compressive strength of the cement will determine how much load it can withstand when hardened with standard sand and water. So another additive cement is the grinding aid. This grinding aid can use to avoid the cement particle to attract each other. Because during the grinding process, cement particle will generate an opposite electric charge to each other. So as a result, grinding aid can boost the rate of size reductions, and because of the cement thickness already decreased, it will increase the species of cement area, optimize cement particle grain size distributions, and finally it will save the grinding energy and increase productivity. So my presentation ends here, and thanks for you watching.
Greeting to Professional Madya, Dr. Malinda Iwana Bindi Idris, and my group member. My name is Ethan Fan with matrix number AD220135 from section 1 and group name is 1B. Today I will presenting processing and manufacturing cement. So here we can see that the cement need to undergo 5 processes, which are extract material, raw material undergo breeding, proportioning, and bleeding, cooling, and packaging to produce the final cement. So the first is extract on raw material. Here you can see that there is a truck at the quarry to collect the limestone. Limestone are the main raw material to make out cement. The limestone will enter crusher 2 times to become small particle. So second step is raw material undergo grinding, proportioning, and bleeding. Mixing iron ore, sand, and clay with small particle limestone. Those mixture will be proportional to the 18% of limestone, while another 20% of clay. Those mixture is feed into grinding mill to become powder. the powder will pour into preheated tower to oxidizing. Next out is burning. The powder is ready to introduce into rotary crank from the top of the screw conveyor. The powder will undergo various chemical reactions until mixture of calcium silicate and calcium aluminate is produced. When the temperature reaches 1510 Celsius, the resultant product involves of grey hardball called clinker cement. The whole burning process needs 30 minutes to produce clinker. The next step is cooling. Clinker is taken out from rotary crank. Wait clinker to cool down to 100 degrees Celsius. Next, 2 to 3% of gypsum is mixed with clinker in horizontal mounds. The function of gypsum is to avoid setting of cement quickly when it interacts with water. So the last step is packaging. The finishing cement will be breathing into silos and ready to package into bags. Each bag having 50 kg and ready to ship in bulk quantity. So that is the end for the processing and manufacturing cement. I hope that my presentation can help you guys more understanding the processing and manufacturing cement. Thank you for Madam and my group member for listening my presentation.
Hi and Assalamualaikum. My name is Hani Suraya binti Hamzah. My metric number is AD2204. And today I will talk about selection of suitable material and processing. Until this day, cement still remains as one of the most important things in the construction industry. Fundamentally, cement can be categorized into two types: hydraulic cement and non-hydraulic cement. The Romans was the first people in antiquity to employ the hydraulic cement. So, what is hydraulic cement? Hydraulic cement is a special type of cement that set very quickly with the reaction with water. With the chemical reaction with water, hydration, and gets solidified with the immersion of water to finely ground cement. It has the capability to react with water under ambient condition to form a solidified and water-resistant surface. The hydration reaction in cement will form a strong solid mass. Nowadays, hydraulic cement is widely used in the construction industry because it possesses properties like non-shrinkable, non-corrosive, and non-rusting. Its material commonly used to stop water and set immediately when exposed with the water. It will set in 5 to 10 minutes after adding water content to it. Hydraulic cement is a type of cement that's same as mortar. It is generally utilized to sealing the structure and in the condition where structure are submerged in the water. Hydraulic cement is made with 3 raw ingredients, which is limestone, gypsum, and clay. And all these 3 ingredients will be burned in the high temperature and often used to close crack and leak in concrete, especially those structures that has weakened with age. This is some of the hydraulic cement uses. Some chemical agents present in hydraulic cement, state the reaction due to the application of water, which causing the mixture to set and harden very quickly, with reducing the curing time of the cement mix. The properties of this chemical agent make hydraulic cement impervious to water damage and to prevent the repair surface from the chemical attack. Hence, hydraulic cement is more preferable for the construction of structure in close contact with or submerged in water or contact with the seawater. Hydraulic cement is exceptionally suitable for projects that require a speedily setting and less curing time. However, it just gives a short window of time to work with it before it solidifies. So, it is recommended to apply hydraulic cement only for projects that should be done in 10 to 5 minutes with a moderate amount of cement mix produced at one time. This is some of the example of hydraulic cement application. So overall, hydraulic cement is a modern invention that reacts with water chemically to gain strength and form a hardened surface. Due to its unique properties, it is mostly used across all forms of construction. Hydraulic cement does not shrink or contact like ordinary cement, and a few mixes even develop solidifying.
Greetings, Doctor. This is Mahmoud Fadel again. To conclude, cement is so important in our lives. We cannot simply express its importance by mentioning the broad usages of cement in our life. Like I mentioned before, building schools, hospitals, roads, and all that. Alternatively, we decided to dig into its manufacturing processes, the extraction of its raw materials, the grinding, the burning, the cooling, and finally the packaging. No ordinary material will have to go through all these expensive and time-extensive procedures to make unless it is so essential in our lives and our evolution. Thank you.